So let's talk clean industry solutions, and we will do this with a company by the same name. So a warm welcome to the CEO, Christian Zahler. How are you doing today?
Hello, thank you. I'm fine. How are you?
I'm looking forward to your presentations. Everything's great. So I'll leave the screen for you, and looking forward to hear what you can tell us about clean industry solutions.
Thank you. Thank you for the warm welcome. Thank you for the introduction. Hello, everybody. I'm glad that I can be with you today, at least per video call. It would be better to be live in Stockholm, but unfortunately wasn't possible, and we're saving quite some CO2 by using video call. So let me introduce you to Clean Industry Solutions. Who are we? What do we do? The name is the program, basically. In Clean Industry Solutions, everything is about clean energy, clean water, with the ultimate goal to achieve a clean industry. Who are we? Clean Industry Solutions is basically an investment company that invests in other companies who provide solutions for a sustainable industry and a circular economy. Clean Industry Solutions is listed on Nasdaq First North since summer last year, and currently has 2 subsidiaries. Both subsidiaries are located in Germany, in Freiburg. Both are spin-offs from the renowned Fraunhofer Institute for Solar Energy Systems, the largest research institute in Europe in the field of solar energy. And Clean Industry Solutions holds 100% of both subsidiaries. What are those subsidiaries doing? Industrial Solar, there's also the name, the program, is a company that offers services from system engineering to full implementation of renewable energy systems, tailor-made renewable energy systems into the energy supply of industrial customers. Basically, we analyze the energy demand of our industrial customers and then come up with suggestions with the concepts, and we benchmark those concepts, we engineer those concepts, and we also realize those systems. Solar Spring is active in the field of water. Their core technology is membrane distillation. I will explain a bit more about this later. And they have a similar setup. They are offering services from system engineering to full implementation of water treatment systems. And those are mainly based on membrane distillation, but also on ultrafiltration. So here we have the overview, the scope of services of both companies, as you see them as a group of companies. And there are also very strong synergies. So the scope ranges from consulting services concerning CO2 reduction, efficiency measures, energy optimization. We do engineering, so we come up with concepts, we plan. We do detailed engineering for district heating, but also process heating. This is a very important topic for us, but also for cooling, heating, and direct steam generation in industry. When it comes to power generation, we do offer photovoltaic, not only the regular flat PV modules, but we also have some other technologies, for example, a photovoltaic fence. More about this later. And when you have heating, you also often have cooling, especially in industry. So we try to cover the full energy demand of the customers in terms of electricity, heat, and cold. So we do have a holistic approach. Last but not least, process water treatment with the technologies of Solar Spring. This means also resource recovery. Very often industry has valuable resources in their wastewater streams. So this is a photo of a so-called Fresnel collector system. It's installed on the rooftop of a factory building in Amman, Jordan. It has a thermal power of about 700 kilowatt, and it can produce steam, or it's producing steam with temperatures up to 225 degrees C, saturated steam. And for this customer, we not only generate the steam, or we not only installed a solar steam generation system, but we also installed a complete solar process heat and cooling system. So in the scope of our contract was also the integration of a so-called absorption chiller. This is a thermally driven chiller. So a part of the steam is used to drive this chiller. And this chiller has a cooling capacity of 580 kilowatt, which is quite significant. And I always use this example because it's this beautiful combination of heating and cooling with the power of the sun. So this is our flagship technology, and we do complement our flagship, the Fresnel collector, of course, with other technologies. So why are we doing this? What is the motivation behind that? You have to be aware that about 50% of the emissions are caused by the combustion of fossil fuel to generate thermal energy, to generate heat. We burn oil, gas, or coal to heat up something. Not only our apartments or houses, but there are many, many processes in industry that need heat. And 30% of all emissions are caused by industry. And let's say industry is the most difficult customer. I don't want to blame anybody personally here, but it's going rather slow. And yes, so it's more about communication to the customers that everybody is already green, but it's going rather slow. And this is the reason why we think it's a very good combination, the business models, the technologies of these two companies, Industrial Solar and Solar Spring, is the fact that 80% of all companies that use water or that use heat also use water in the process. And membrane distillation is a thermally driven process. So membrane distillation needs heat as a driving power. And industry needs a lot of heat and water. Let's have a closer look at this heat demand in industry. So you can see here a pie chart. You can see the share of industry, like 32%, and how it's currently covered, or in what form this energy is required. So only one fourth is electric energy, and 74% are required as thermal energy. And this graph now is not from 2022, but it's not too old. And you see here that almost half of the heat is generated with coal. So this is surely not in Sweden, but if you look at countries like Australia, South Africa, or Indonesia, India, it's common practice to have coal-fired boilers. Here in Europe, it's more natural gas, mainly natural gas, which is now very expensive due to the crisis or due to the war in Ukraine, and oil, which is not really cheap anymore also, and a little bit of renewables. And then when you look at the temperature distribution, you see that industry needs some warm water or heat below 150 degrees C. That's about 1/3, another 22% in the medium temperature range up to 400. And the upper half is temperatures above 400, that's glass and metal and other processes. Industrial Solar, our subsidiary, is addressing the lower half up to 400 degrees C. So here you have some industries that are using heat. This is no surprise. Chemical industry, food and beverage. There are plenty of examples that you can think of in food and beverage industry that are using heat to drive their processes, but also other processes like machinery or mining and so on. And where is this all happening? This is also an interesting fact, which I already have shown before, but I show it again and again to make people aware of that effect. if you look at the OECD countries and the non-OECD countries, the emerging markets, and where is the growth to be expected in the next couple of years, in the next decades, it's not going to happen in the rich countries, in the OECD countries like Europe or North America. It's going to happen in the emerging markets like China, India, Africa, Latin America. And this is due to the fact that we don't have this growing population in the OECD countries. We have very good efficiency measures in industry. We're saving energy, especially when it's expensive. Now it works quite well due to the high prices. And the growth of population, the growth of industry, this is going to happen in these emerging markets. And it's also clearly visible that those countries and regions are quite sunny, or most of them are very sunny. So there it's absolutely feasible to use solar energy for industry. The synergy, or this so-called water energy nexus, is also interesting to see. So here you see the development over the last 100 years in emissions, CO2 emissions, and the global freshwater use. And it's also no surprise that it's going in parallel. So we not only have a CO2 problem or emission problem, we also do have a freshwater problem. I mean, there's plenty of water on our planet Earth, but most of it is salt water. And we have more and more droughts. We have more and more pollution. So clean fresh water is scarce. What technologies are we using in our systems, in our projects? I said before, we do have this in-house technology, this concentrating solar thermal system, the so-called Fresnel collector, a linear concentrating system that can generate temperatures up to 400 degrees C, that can generate steam. And this we are complementing with other technologies like photovoltaic modules, regular solar thermal, non-concentrating solar thermal to generate temperatures up to 100 degrees C, roughly. But also different types of storages, electric storages, also heat pumps. So we do basically the sector coupling in our projects, heat and cold combination, converting electricity to heat. And this can be done with heat pumps. And this heat can be stored in heat storages. We can also use the brute force method for high temperatures. That's electric resistance heating for temperatures in a range that heat pumps cannot reach. And then this is complemented by the water treatment and the cooling technologies like compression, absorption chillers, and storages for cold. This is quite a portfolio, but it goes very well together. And this is typically what customers require when they want to become carbon neutral or when they significantly want to reduce their emissions. In this map, you can see the references of both companies. You see in orange the reference of Industrial Solar, in blue Solar Spring, and the other one, the striped ones, are companies that both companies have references. So we were traveling quite a bit in the past, and during the pandemic, we had to stay home, and we worked in our domestic market, and we are now also doing PV solar thermal heat pumps and storages in Germany, in southern Germany, and this is picking up quite well, mainly due to the high energy prices due to the war, but also the understanding of climate change. Everybody has understood that we have to act, and the high prices are basically accelerating this effect. One technology which is very interesting, I think, this is for customers that already have their rooftop covered with PV modules. This is solar fence. The design is by the company Next to Sun, and you see here a photo which is quite new. This is our first reference. It's an installation of a so-called PV fence with bifacial modules. So those PV modules generate electricity when they receive solar radiation from the front or the back, unlike regular PV modules. And this system is installed like 50 kilometers north of our headquarters here in Freiburg. The customer is Hydro, this Norwegian company that you might know, Norsk Hydro. It's a subsidiary of Norsk Hydro here in Germany. And we installed a fence for them with a length of about 420 meters. Very nice project. And it was installed like 2 weeks ago. Here is another photo from the same project. And what's also interesting for industry that has already the rooftop covered are PV carports. And here is an example, a photo from ClickCon, a technology provider for carports. And here you see a carport that can also be applied for industry, for larger vehicles like trucks. They can overspan rather long distances. So you can maneuver with large vehicles, not only with regular cars. Coming back to our core technology, when energy was cheap and gas was cheap and oil was cheap, it was, of course, very difficult to sell this technology. Suddenly, we are receiving lots of requests for this technology. This is a linear concentrating system. It's an approximation to the so-called parabolic trough. And it has some advantages. It needs less area. It has no moving absorber tubes. It's the best technology to generate steam directly. You can also use other heat transfer media like pressurized water or superheated water under pressure, or thermal oil to go to very high temperatures. So this is really a very good and excellent technology to meet the process heat demand in industry in a temperature range from like 140 to 400 degrees C. And it's modular. It's designed for the megawatt range. We need about 3,000 square meters for 1 megawatt, or 3,000 square meters of roof or ground. And the sweet spot is in the range of a couple of megawatts. So 2, 3, 4 megawatts is nice. Below 1 megawatt, it's a bit costly. And when we get very large, the price is not, the costs are not going down significantly. So it's asymptotic. It's big enough to meet energy demand in industry, but it's still small enough to be installed on these large flat rooftops. Direct steam generation mentioned before, it's very nice to integrate. Basically, we need a valve and connect to the steam header of the company that operates a regular steam boiler, and we inject steam and keep the pressure in the system, and the burner doesn't fire fossil fuel. As simple as that. Heat pumps, already briefly mentioned, this is of course a very interesting technology to convert electricity to heat with good COPs, with good efficiencies. There are more and more technologies or manufacturers of heat pumps that offer systems for industry that can also achieve higher temperatures. And this is also part of our systems. Now coming to our other subsidiary, Solar Spring. As said before, their main technology is membrane distillation. This is a thermally driven system. You can compare it to your outdoor jacket, to Gore-Tex, Sympatex. So you have the hot feed solution, and then the water evaporates through the membrane, and then you have a condensation surface behind, which is cooled, and there the water is condensing. It can be very easily operated with waste heat, for example. It's very robust. And you can concentrate to higher concentrations on this side of the membrane, which makes it interesting for concentration of valuable components or for zero liquid discharge systems. What are the applications? Some examples: metal industry, galvanization, recycling of acids in metal industry, but also brine treatment. A lot of wastewater in industry is contaminated with salt. Water desalination with reverse osmosis. It's not always possible to dump the concentrated salt water back in the sea or in the ground. So with membrane distillation, you can concentrate the salt to much higher concentrations, and you can even design zero liquid discharge systems. It's possible to remove ammonia from wastewater, from a sewage water treatment system. Ammonia is a problem for our rivers and lakes, and at the same time, it's a fertilizer, so it's a win-win situation. And it can also be applied, the technology, for fracking, for example, and cleaning the water. The most interesting, I think, now is the latest development. Hydrogen is a very important component to decarbonize industry. It should replace, on the long run, natural gas. And it's very attractive to generate hydrogen close to an electric power source, to a renewable electric power source, for example, offshore wind parks. And for the electrolysis, you do need electricity and you need ultra clean water. And the electrolysis generates waste heat. And this waste heat can be used for the membrane distillation for the production of ultra clean water. So this is increasing the efficiency of hydrogen production and lowering the cost. So let me summarize. We do have a global market with a tremendous growth. We have a strong order intake. Here you can see the sales figure of industrial solar. We have an increase of 300% compared to last year. There is a huge demand now for green tech solutions due to the climate crisis, but also due to the war in Ukraine. Fossil fuel is suddenly very expensive, and we don't want to be dependent on fossil fuel anymore. If it comes from Russia or if it comes from other countries, we should improve our independency and use more renewable fuels. And there are new regulations and guidelines on the way from which we will profit, because it's obligatory to use renewable energies, and this is helping us. So we are very well positioned, and we offer good solutions for our customers. Thank you. That's it. Thank you, and looking forward to your questions.
Thank you so much, Christian. I remember you were saying previously that you were not content with the size of your orders. You say now that there are many in numbers, but have they developed in the right direction in terms of their sizes?
Yes, I mean, the larger the project, the longer the discussion, negotiation, preparation. I mean, you can get smaller orders rather quickly, but if a company has to invest a couple of million euros, then it takes long. And as I said before, industry is more difficult than private customers. Private customers have an emotional component in their decision-making process, and industry basically or mostly looks on the financial figures. And renewable energy systems have the problem that they have a rather high capex, a rather high initial investment, and then they have a payback time, amortization time. And even so, this amortization time is maybe only 5 years, which is excellent for renewables. I mean, before the crisis and without subsidies, you could have like 15 years payback time, which was an absolute showstopper. Now we are down to numbers like 4 or 5 years, sometimes 3 years. But this is still a problem for industry nowadays, because many companies don't even have this time horizon. I mean, a CEO lately said to me, I don't know if my company will still be here. Maybe in 3 years, it will be relocated to India. So this is a problem. And not only we are suffering from that. If industry has to do investments in energy infrastructure, then it's not their core business. They basically want to pay it monthly. And one measure is energy contracting, so that we team up with financial investors that take the capex, and then the customer is paying his monthly bill. Yeah,
thank you. You seemed a bit disappointed about regarding the reductions of the emissions in the industry. They are going quite slow, you said. Yeah. What is needed in order to change this?
That's a very good question. I think it's really our system. I mean, let me give you an example. If you look at the hotel branch, hotels, you could think, okay, they need heat pumps, they need cooling and heat, and it should be very attractive for them. The payback times are very short, but typically hotel managers are employed with a rather short contract. They're like 2 years.
Mm-hmm. So they're not interested in making the big changes.
And if they invest in a renewable energy system with a payback time longer, they're messing up their KPIs, they're messing up their financial figures, and they're probably going to be fired after 3 years because the EBIT was too low. So this is more a systematic problem. and yeah, makes it even
let's be more
difficult.
specific. What are the changes that you are waiting for in your position in your company? What are the changes in, say, in terms of new legislation, new compliances that could boost your growth?
Sure.
Is there anything to expect that could change your?
I mean, here in Germany, we have the obligation now that every commercial building has to have photovoltaics. Also, like parking lots have to have PV carports, and the thermal part is always more difficult. I mean, people tend to look first on electricity. It's like the lower-hanging fruit. Its systems are simpler, but at the end of the day, we have this huge thermal demand in industry, which is really difficult, and everybody is hoping for green hydrogen. But if you look at green hydrogen, at the efficiencies, at the costs, solar heat is much cheaper, much simpler, especially in region where it's a bit more sunny than in Sweden or Germany, further down south, of course. But yeah, everybody is hoping for the Deus ex machina, for the solution and for one solution. And many people are hoping that hydrogen is it. But we need all technologies. There's a whole bunch of technologies. I was presenting our portfolio. And we have to understand there is not one solution for our problem. There are many, and we have to use them all. We have to apply them all.
You are talking a lot about the emerging markets and how the demand is big, specifically in that region. So one of you would like to know, how strong is your pricing power since you deal with these developing countries?
I mean, of course, in developing countries, but it's often large corporates. So the customers are not small companies. It's bigger companies that are either supplier.
So it's national groups that you are dealing with, not
international
locally
groups
based.
Also. It's both, I would say, but the large corporates that have sites all over the world, production sites, be it for textile or food industry, there are a lot of multinationals around. And of course, if you look at costs, they always want to have the lowest cost. They don't want to pay a cent more than they paid so far for fossil fuel. Makes life hard, especially when you want to increase your business. I mean, we don't have the production volume to really optimize the cost yet. This is a chicken egg problem. If you would have the volume, costs would be lower. And this is still the hard phase when you have to sell a technology which at a price which is caused by those smaller project sizes and smaller volumes, of course. And we have to overcome that phase.
Okay. That should be the last questions as time is running out. So thank you so much and good luck with the development. Thank you, Christian. Thank you. Warm applause here from Stockholm.